just to get some review in and get the blood flowing. So we'll do this one, print the multiplication table of some given n. We'll say like n is equal to 5. We can make that little data object. And now we kind of want to multiply it by 1, by 2, times 3. So when we see that kind of trend of counting up, we can say, this sounds like a loop, and we can use the range function to kind of get 1 through 10. So with the range function, we can see it says what to do. We can begin at 1. We want to stop at 11, because if we stop at 11, the last thing we actually get back is 10. 11 is kind of a stop sign. We don't go fully to 11, we just get to 10. I could specify the step, I'm going 1, 2, 3. I'm just incrementing by 1. But since it's the default, I can just kind of leave it out. And then I can just say, I'm going to multiply this num, which is going to be 1, 2, 3, all the way to 10, times this n, which is going to be consistent. And then I can just print out my product like this. And then what I get is, 5 times 1, 5 times 2, 5 times 3, all the way to 10. 5 times 10 is 50, just like that. And then obviously, just again to explain kind of loops, each time we loop, we do all the code kind of indented, and then we come back up to the top. And then even though this was something in the last loop, we basically put a new value in each time. So we just use the same name again and again. So at the top of each loop, I say, okay, last time I did 1 times 5. Now I'm going to be 2 times 5, and that'll be the new product. So I can just keep using this again and again. It's a multi-use little object I have inside the loop. That's how we can do something simple like a multiplication table. Let's see what else we can practice with. So let's see, we can say, let's get only the evens between 0 and something. So say only evens from 0 to n. We'll give n as 10 this time. And this sounds like we might need a loop again to be able to count up. So I'm going to call my item that I get out of each loop. I'm just going to call it even. I'm going to use that range function again. And now to do this, we want to begin at 0. We want to go to n. So in this case, we want to stop at 11. So I could type in 11, but I could just do n plus 1. So that way this is dependent on this, and I don't have to change both of them if n changes to something else. So this is going to be the stop point. And now since I basically want every opposite thing, I want to count 0, then 2, skipping 1. This is when I use that step to kind of increment twice as fast. And I could do something like that. Let me take this out so it's not so crowded. So we can do something like this. And then we get that. And then if we look at the next one, how do we get only the odds between 0 and n? Well, in this case, it's almost the same thing. If we go from like 1 to 3 to 5, we still step by 2. But in this case, we just have to begin at 1 so that each time we add 2, we get to the next odd. So if I just change this one thing, now I can do all the odds. And if I want all the evens, I just begin on an even like that. So that's how we can do those simple questions. And those are a good illustration of using the range function with a loop to get something. If we want to do something like do a countdown, we'll do this 5 to -5, 1. We can say, let's set up a loop. Obviously, we'll use that range function again. I can go ahead and put what I'm going to do. And now let's see how we'll set this up. So we just have to go slowly. I know it'll take a while to get used to how to kind of count. So we can say we want to begin at 5, so that's easy. We want to stop at -5, so that means actually we want to put in -6. And now we want to count, we want to go 1 by 1. So if I put 1, it's not going to give me back anything. And that's because I'm counting down, so I actually need to increment by -1. So if I do this, I go 5, increment by -1, drop down, and so on. So we can use -1s to kind of count down and go the opposite way, like that. We'll do one last one. Let's take a look at this multiplication table again, which we did a couple of minutes ago. But now we want to print like multiple multiplication tables at once. We kind of want to do 2, 3, and 4 from 1 to 10. So if we just do this again, we can say, let's just set up one multiplication table. We'll say n equals 2. We'll just copy what we did a second ago, like this. If we do that, that's how we get one multiplication table. And that's pretty easy. The kind of the cheat way would just be, let's just copy this code and we can just change this like this. And then we get 2 multiplication tables at once. But that's not the best way to do this. And this is not, how we want to think when it comes to coding, because this is a lot of copy and paste, a lot of code, when we could do it with a lot less code actually. So if we think about it, this is all we need to do, but we just need to do it 3 times while changing n. So what we can do is we know how to get 2, 3, 4 with a range function. So if we do something like this, well, this is how we can get these digits, by ranging 2, 5, 1 like this. And now, how do we combine these 2 loops? Well, we can just put this one inside of this one. We can nest all types of things in Python. We can put something inside of something, that's totally fine. So now what I'm basically doing is I'm saying for each of 2, 3, and 4 like this, I'm going to do these steps. And now instead of this n, which is just 2 at the top, I can swap in with this. So now this is dynamic and this is going to change each time we run the outside function like that. So now if I run this, we can see I get my 2 multiplication table, and that's 1 loop of this. And then when I finish this, I get to my second item. This now becomes 3. And then I do this whole thing again with just the 3. So we can see I get that. And then one last time, we can see I go up by 1. I get to my last number from this range. And then I do this whole thing again. So this kind of idea of stacking, nesting loops is kind of a big idea in Python and programming in general. It's a bit of a tricky concept to get an idea of. Maybe we didn't even realize that we could do this yet. But we'll keep this in mind as we go along. We can, stack things up as much as we want in Python, put things inside things, all the kind of stuff like that. So this is all these solutions to the ones we missed. And if you want to, go back and look at what we did. This is something we kind of passed by at the end of last class. I'm not going to spend too much time on these Python commands. I have the solutions in the handout in front of us. Basically, what these do is that they help us control the loops that we make. And what they do, simply break kills a loop completely. So if we look at this, we know what this loop should do. It should count, 1 to 5. But what happens is anytime we see a break inside of a loop, it just kind of kills the whole thing and goes on, to the next line. So you can see what happens is we print once, and then we break, and then we skip all the remaining loops, and then we just go on with the code. So we can use this to kind of kill a loop if we want. If we take a look at this one, in addition to kind of breaking a loop completely, we can just break one iteration of that loop. So this is the same thing, 1 to 5, and I can use the continue statement to basically skip my second loop. So if I equals 2, I'm just saying continue on, I skip this, and then I go back to I equals 3, and then I keep going. So this just breaks one cycle of the loop, the continue statement. And then finally, we might see this on occasion pass. We can think of this as just kind of like a placehold to put in place. If we have something like this, say I'm setting up some code, I know I need an else, but I don't have any code yet. If I want to test my code, I can't do this because Python needs something below the else. So instead of needing to go on and fill in the code, I can say, let me put in pass to kind of say, I'm going to come back to this, but I'm just kind of placeholding the spot. So this is what pass does. It just kind of like holds an empty spot until we come back and touch up that code. Okay. So the question we'll take a look at this kind of coin calculating program. We'll skip the next two, and I'll leave that to you to look at the solutions just for the sake of time. But let's take a look at this one now, and then we'll move on to this week's content. So in this one, we want to write some Python code that accepts some amount, some amount of money. I have something down this way, 525, anything you want. Accept that as an input, we just, as a data object. And we want to give back the same amount in change, in the least amount of coins possible. So as an example, if I just had 0.25, the least amount of change back I would give would be, one coin. If I had something like a buck even, my change would be full coins like that. I want to give back 100 pennies. I'd give back the least coins possible. So that's what we want to do in this program. So that's the idea of what we want to do. I kind of have two ideas of how we can kind of calculate what coins that we'll get out of this. But the basic shape of it is, how do we get the biggest coins and then the smallest coins? Well, the basic idea is we'll basically say if we have some amount of money, let's take out as many of the big coin as possible. And then once we can take out, any 25 cents, then we'll say, okay, how many dimes can we take out? And then once we can't take out any dimes, we'll say, okay, let's go on to nickels. And then lastly, we'll go on to pennies. So we'll go in that sequence, big to small, and that way we'll always get the least amount of coins because we'll be getting the biggest denominations at the top, and then we'll wait to get the pennies all the way at the bottom. So that's kind of like the human logic behind it, but let's take a look at how we could do it in Python. So to begin, we obviously, let's set up some data objects. That's what we usually do at the top of some code. So we'll do something like this. I'm just going to abbreviate the coins, pennies, dimes, nickels. I'm just going to call them QDNP. So that's going to be my kind of tally of how many of each coin that I get. I can change. Let me move that down next to all my objects. And let me change it to 67 cents, just because I've already calculated, what it's going to be, so we can test it once we get a solution. And now what we want to do is we basically want to say, okay, beginning with the biggest coins, how many can we take out, and then take those out, and then we go on to dimes, then we go on to nickels, and then we go on to pennies. So that all makes sense. We can kind of, intuit that. It's just kind of like, human thought. Now let's put it in code. So one way that we could do this is we could do something like this. We could say, while change is above or equal to 0.25, keep taking away 0.25 and adding that coin to the tally. So if I have $1.25, I'm basically going to say, okay, $1.25 is above 25 cents. Take away a coin from the pile of coins and add a coin to my tally. And then once I'm below 25 cents, say instead of $1.25, I had $1.27. At some point, I'm going to have 2 cents left. I'm not going to be able to take one of these coins away. And now I can go on to see, oh, can I take out any dimes, any nickels, any pennies? So we can set up a little loop and just say, keep taking away a coin as long as we can. And then obviously we can just do the same thing with this. While change is above 10 cents. Oops, mixing up my object names. I'll say take away 10 cents and add a dime like this. Same thing with nickels. While change is above or equal to 0.05. Take away a nickel and add that to the tally. And then finally, we can do the same thing with this. While change is above or equal to 0.01. Change, take away a penny and add that to the count. And then at the end, we can just print out a little statement so we can see what happens. We'll see today how we can kind of speed up these print statements. But for now, I'm just going to kind of do these ugly ones. So it's going to put a whole stack of them. We can click play. So we got 2, 1, 1, and 2. And if we go back up to the top, that's what we should get, 2, 1, 1, and 2. So we got 67 cents. And we can get, we can do it in just 2, 3, 4, 5, 6, 6 coins like that. So that's one way that we could do it. We could just use a bunch of while loops and do it that way. But we could do it a different way. So if I want, I can just take away one of these and say, how else could we do it at this point? Well, we could say, dimes is equal to change divided by 10 cents. And I'll explain this in a second, obviously. Let me just double check that it comes out the right way still. Okay. So what I'm doing in this case, instead of doing a while loop and taking out one coin at a time, taking out a coin, adding it to the pile, we could do it this way. We could say change, let's say we have 70 cents. We could say, okay, what's 70 divided by 0.10? That would give us 7. And then that's just getting the solution. Then we have to say, okay, actually take 70 cents out of the pile of change that we do the calculations on. If we have, let's say we have 71 cents. This is why I'm using this special division symbol. We talked about this last time. This is the kind of whole division symbol. So if I have 71 cents and divided by 0.10, it's still going to give me back 7 instead of 7.1, because it only gives me back how many times I can divide wholly into that amount. So I still get 7. And then I say, okay, change, which is 71.71. Let's do that 7 times 0.1, that's 0.7. And then I'm going to be left with 0.71 minus 0.7. it's going to give me back that penny. So I don't have any rounding issues using this special type of division. I can basically speed up this. In this case, I do one coin at a time. In this case, I basically just say, I don't need to take away one dime at a time. I can just divide and see how many whole dimes I can take out. And then I just take out that amount of whole dimes like that. So instead of doing a bunch of while loops, I could copy this code for each of these, and then you could do it that way as well. Basically the same thing, they'll both give out the exact same solution. No real, at this point, benefit to either one. It's just good practice to see, which one, multiple ways to do it at this point. This one might make the most sense to you because it's easy to just take one coin out at a time. This one might be the most elegant because you can just do all of it at once. You just have to have kind of handle on, the special division, and you could do it that way instead. So that's how we could do a question like this. Not too bad. Like we said, the pseudocode, just kind of planning out the steps was easy. Set up the data objects, and then it was easy enough to say, begin with the biggest coin, go to the smallest coin. And then we just had to use a couple tricks, and we had a couple options to do each coin along the way like that. So that's how we could do something like that. I have the solution hidden in that box, the full solution of each method. These next two, unless someone did this at home in the last week and you have questions about it, I'm just going to skip by it now. I have all these solutions in it. Not too bad to do these two questions. So if you don't have any questions, we'll move on. If you look at it at home and have some questions, you can ask me at the top of next class. Let's go back and take a look at that. That's fine. But if not, we'll go ahead and jump into this week's new topics. Okay. So just a little bit of review again of what we've done. We now know how to do data objects. We have the multiple primitive data objects. So we can do string, which is text type, and we'll be looking at that today in the next class. We have the two quantity types, whole amounts and decimal amounts. And then we have the Boolean, which is true and false. To make any of these, you just assign a name and then put one of those values inside. And Python automatically intuits the type. It knows if something is a bool. It knows if something is text because you put it in quotes. So that's all pretty easy. And then I have the second type of data object down at the bottom, which is that sequence or that collection. And basically, we can think of these collections as just kind of a bucket to have multiple of these data objects inside. So we can think of these as single data objects, and then this list as something that can have a lot of those data objects inside it at once. The list we just make with these brackets. We can just set them up, commas between values. And then to add a new value, we just use this .append function tagged onto the name of the list as we get it. And we'll look at those again today as well. We've done conditional logic, so we know how to kind of split along the way of coding. We can do not just one set of instructions to all data, but we could say, if something, let's do this, else let's do that. So we can kind of decide when and if we do things. We use these a lot to, in conjunction with this conditional logic, the less than, the not equals, is something equals, that double equal sign. So that's how we can kind of check equalities, true, false, these give back. We looked at these last time, just kind of helping tools. You can kind of combine expressions like this with and not and things like that. We got the basic math symbols. We have the two types of loop. And this is actually a typo. So we have the two types of loop. The while loop, which just keeps going until we until the condition next to the while loop fails. And then this type of loop loops as many times as items that you give it. So we use that with the range function. We specify, do this 10 times, 1 to 10. We might say loop a list or loop a string, and we'll get back each element of that object. And we'll look at that again today as well. And then we just looked at these as well. And so if we take a look at the kind of the list of Python statements, we have a decent chunk of them. And we'll be adding a handful back today, back in today. So at the top, we have to talk about custom functions. So we've been using some functions in Python. And again, a function is just something that has some input. You give some input to the function. Something happens inside the function. We can think of it as like a machine along an assembly line. Something happens, and then it has some output. Something comes out the back end. We looked at functions like type and print and input, and all of those, you can input something into them. Type, you can give an object and you get back the type of object. Print and input, you can give it a message and that helps, print something, stuff like that. Python has built-in functions like the sum function, and that you can just give like a list of digits and it can sum them all up, get the total. So we have a couple built-in functions, and we'll take a look at those in a second. But we can also make custom functions. So we can define a kind of block of code. Say, we expect some input, and then we kind of write out the set of instructions as to what happens to that input. And then we give back out some output of that function. And the use of a function is that we can kind of use it again and again. When we write a function, what we do in step 1 is we just define it. So we kind of write instructions, but we don't actually do anything with it. The instructions just kind of exist, and they kind of wait doing nothing until at some second point, we actually call the function. So we say, okay, let's actually use this function that we defined. Let's give it the inputs, and then we can get back out those outputs. So a function, it can have as many inputs as you want, and we can just separate them by commas, as we'll see. But let's take a look at the basic kind of shape of what a function looks like. So step 1 is we define a function. The way we do this is we say def, as in definition, and then we make up a function name. You can call it anything you want. And then we have to open up some parentheses because all the functions that we've seen have parentheses. And the point of those is that inside them, we can put the inputs that we expect. So basically, this is saying the definition of some function, what we'll do in this function, given some input A and B, is thus. And inside the function, we kind of indent the code to kind of define the code block, just like with ifs and loops. We indent it to say all of this code is inside the function. And then that kind of doesn't do anything. We just defines some instructions. When it actually does something is when we call the function. And if we look at this, this is when we call it. It looks like just like when we use the print function or the type function, we just list the function name, open the parentheses, and then give it the input that it wants, that that machine runs on, that little thing along the assembly line. We can do it like that. To go a little bit advanced, we define the function, we get the input, and then how do we kind of send back things outside the function? Again, if it's an assembly line, a machine along an assembly line, this is the kind of input along the conveyor belt. And then this line is how we'll send things back out. This is going to be the output. And this is some data point that maybe we make inside the function, given the input. And then basically we send it back out so that the place that we called it, if we take a look down this way, this kind of looks like things that we've done with the type function. We call the function, give it some input, and then we get the output that comes from this line. Just one thing ahead of actually doing a little example, we can see that these don't all have the same name. So inside the function, I'm outputting something called variable. But when I actually call the function, I'm calling it output. And that's totally fine. These names don't need to match up. Just like when I call the function and I give it something called input1, my definition of the function expects some input, not input1, but that's okay as well. They don't have to match up. They just kind of have to be in the same place like this. So let's take a look at a simple example, and then we might get the feel of how this all flows like this. So let's make a simple function that kind of does a summing program. We just want to kind of total up this list of digits that we got going on. So this is the data that we use. So to begin, step one, we'll define the function that we have. So again, just always def. You can see it highlights blue, so Python knows what's going on. And then we can name it something. I'm going to call it add up. Open up my parentheses, put on a colon, and then I indent to say all of this is inside the body of my function now. Next, let's go ahead and say, well, we need some data. So let's say I'm expecting something, and we'll call it nums. So if something is given to me, I'll call it nums, and I'll use that inside my function. Then we can do a little bit of the actual code. So if we want to do, so this function is adding up all the numbers given. We can just say, okay, we need some total. Then we'll say we'll go one by one and just add them to the total like that. And then the last thing we need to do, this is the output line, and that'll send the data back out. If we push play on this, we can see it doesn't do anything. It's okay. So we can see what happens is we get this print statement. This is just defining the function, so nothing actually happens yet. And we can see that's kind of skipped, and then we get calling the function down below. And now we can actually call the function. So now that we have a function on the page, now we can actually call that by its name and actually use it. So we'll say add up. Let's input into it. Input, which is these nums from above. We could run this. And what it's actually doing, well, we could do it this way. Let's print out what it's giving back. And we can see it's now summing it up. We could also do this. We could say, solution equals add up. And then we can print solution. In this way now, we can use this down the line. So we can save the data, save that output as something called solution. It was called total inside the function, but when you pass it outside the function at this point, it basically loses its name. It just becomes a piece of data. And then we need to stick it back inside an object that we'll call solution. So the name change is okay again. And that's how we can do that like that. A couple last things about functions. Objects kind of made inside a custom function. It's something called local, meaning it's only kind of usable inside that function itself. Again, if we imagine a function as like a machine along an assembly line, it has the moving belt feeding into it. And then inside the box, some whole set of steps is happening inside that machine. And then out the back end, the moving belt gives out like the finished product. We can see the input going in. We can see the output that is explicitly given back with this line. but all the stuff kind of inside that machine along the belt is kind of invisible outside that machine. So what does that exactly mean? Let's take a look at this example. So in this one, I just have a function called hello. And all it's doing is inside hello, I have some name2 called Matt. And I'm just printing out hi, name1, and name2. So if I print this, what is happening is I'm calling hello. And then inside this function, it's saying, okay, let me get name1, which is established outside the function. So this is what's called global. It's accessible any place. And then it's saying, let's say, hi, name1 and name2. This is what's called local. So it all looks fine now. But what happens if we try to print name2, which is made inside the function, outside the function? What's going to happen is it's going to say, at this point, Python doesn't know what name2 is. And that's because we made name2 inside that kind of machine along the assembly line. And crucially, we didn't do something like this. We didn't give name2 back outside of it. So it's kind of left inside the machine and inaccessible down the line of the assembly belt. So while anything kind of at this global scope is available inside the function, stuff made inside the function is not available outside the function. So that's why we get a bug with this line, but we don't get a bug with this line because name1 is available inside the function. So it's kind of a one-way thing like that. So we just have to keep that in mind. If we want something available outside a function, we'll need to hand it back. So if I want to have access to name2 outside the function, I could do something like this. Hello is going to spit back out that name2. And then I can uncomment this. And then I see I have access to name2 kind of along the whole code, because even though it was kind of invisible inside the function to begin with, I pass it outside that little machine. So it's available along the whole assembly belt of the code now. So that's one of the few things we have to keep in mind with functions, just how we can handle data like that. Okay. So now let's take a minute to, now that we have the ability to make functions, and we'll make a couple today, custom functions. One thing we might want to think about, and that we've seen a couple times now, is bugs. We've seen bugs happen. Up until this point, we've just kind of said, if a bug happens, we'll just kind of not pay attention to it now. But when we code, sometimes we want to anticipate bugs. Sometimes we want to handle bugs, kind of elegantly instead of just having Python crash. So let's take a few looks at things that can kind of accomplish those things. So when writing functions, we could run into bugs a whole lot, unlike what we've been doing up to this point with just kind of free floating code. And that's because with functions, we have the ability to call them as many times as we want. So if we see up this way, most of the code that we've had as of now, we can only kind of run it once unless we put it inside of a loop. But as soon as we have a function, we can use it again and again and again, any place we want after we've defined it. So because of that, bugs could happen because one, we wrote function X a while ago, and we've just been using it again and again, so that could bring about bugs. And then the second thing is, since we can use something again and again and again, that little piece of code, obviously if we use something again and again and again, we might be using it in the same exact way, but we might have tried to make it kind of a multi-use piece of code. So it might take some variety of inputs and things like that. And because we've tried to kind of make it be as multifunctional as possible, bugs could happen if we give it some piece of data that we didn't quite anticipate, and then the whole code crashes because of, you know, some logic thing, or maybe we don't have the correct type that we should, things like that. So let's take a look at the actual tools now. So one is a function. We know the type function. This type function just gives back the type of something, and we can just kind of print out what type gives back to kind of check what something is. So we could do something, you know, like this. We know that's a string. We can check, you know, this is a bool. So we can do that check, but kind of the 2.0 of this function is the isInstance function. And this basically, instead of telling you what something is, it's going to check what something is based on what you provide it. And it's going to give back a true false based on that. So if we take a look at this little bit of code, this is basically saying if Matt is a string type, then print out this line. And we can put in an else, and I'll just say else. So we can see this is a string, so that's good. If I change this to say, I'm checking if this is going to be an int, we can see I get to this line. If I change this to bool, that's obviously still going to fail, but this passes just fine. So when we make functions and we feed it data, we should be anticipating some type of data. So like with that add up function that we just did, we should anticipate that we should have maybe a list to begin with, and then inside the list, each piece of data should be maybe an int, maybe a float, maybe it's fine that it's both of them. So now we can use this tool to just kind of check along the way. And then maybe if we get in that add up function something that's not a quantity, maybe if we get a string, obviously we can't add a string to a quantifiable total. So this is when we could say, at this point, we know that we don't have the type of data that we could expect. And then we could do one of these two tools. So down this way, we have raise exception. And then we have these type and value bugs as well. So so we take a look at this add up function. It's the same thing that we had previously, but I just added in a lot of code to kind of make it protected against bugs. So we'll just run down the definition and see what's happening now that I have all these new things inside of it. So one, define add up, expecting something called nums. That's something that we did previously, so that's fine. I begin with my total equals 0, that's fine. I kind of loop num by num to get access to one at a time. That's still the same. But now that I'm at the point of each individual item and I'm going to check, you know, is it an int or is it a float? If so, I'm actually gonna do a second check just so we can kind of see all the types of things that we can do. So in this example, I'm just assuming this type of sum function can only sum up positives. That doesn't actually make sense, but just for the sake of this problem. So what we'll do is we'll say, okay, we want to check that we have some type of quantity, and then we want to do a second check. So if it's negative, which I'm not allowing in this function for some reason, then I can use this line, which is above. And basically what I'm doing is manually raising one of these bug statements. So instead of just letting Python kind of guess and try to catch it, I'm going to explicitly code it in myself. So it's going to be kind of safe in that way. A human kind of coded the bug statements this way. So what's happening with this? Yeah.
Are you giving separate like 5-10 minutes to ask questions, or can I ask questions in between? I'm not.
Oh, you can ask questions as we go. Yeah, it's about the question.
Okay.
Again.
So for this, what you have just highlighted right on the screen, similar to this function you showed one before, I know.
Yeah.
So I had few questions. So here, like the very first line DEF, which is written in blue, that is for defining. That means like I am defining that add underscore up function, right?
Yeah,
And the parameter or argument of that function is nums, correct?
yep. Yeah,
Okay.
exactly.
So now the next, I'm not reading the comment, total equal to 0, completely understood. You introduce that variable and it is an integer variable 0.
Yep.
Then the very next sentence, for the for loop for num in nums, which you had before also, that
Yep.
nums num ending with s is defined there exactly where you are
Yeah.
highlighted.
Yeah,
But
exactly.
for num for that one, like that you are just dropping in there. It was never anywhere before defined, right?
Yeah,
It means
so anytime we use this type of loop, this
Mhm,
has to be some pre-existing data point. But the
mhm.
thing that we call each item of it that we check out, we go one item at a time.
Right.
This we can always call anything we want. So when I call it num, this is the only point on the page that I've used num up to this point, and that's fine because I'm making the name at this point. Yeah.
You are making up that num, right?
Yep, I'm making that up right now. That's just what I'm calling each item out of nums.
Okay.
Yeah.
Okay. All right. I had another question. I can't remember right now, but yeah, go ahead, please. Thank
Okay,
you.
yeah, you can ask us once it comes back to you. Okay. Yeah, so again, we just check, since we want to catch and anticipate all the bugs, we just check, is it some quantity? If so, we want to check if it's positive. If it's negative, we kind of manually raise. In this case, I'm going to use a value bug because it's a value mistake. It's supposed to be positive, it's negative, so that has to do with the value. And then if this doesn't pass, if I'm positive, then I'm doing this total plus equals num. And we could, if we want, do this. It's kind of the same thing. You know, if it's negative, do this, else. If it's positive, do this. And then we come back down to this. This is kicking in if I am not an instance of int or float. So if I input some data and it has, elephant in it, I'm going to get kicked to this line of the code. And then I get this statement like this. Just like that. 1 second. Okay, yeah, so that's what this looks like. So at this point, I'm just kind of manually printing out something. And then what I'm doing in this line is I'm basically cutting the function. I'm in the middle of the function. I haven't looped each item to add up to the total, but I'm saying, let me output of this function. Let me cut it now. And this is a special data type called none. It's one of the data types like string and float and bool. And the none type data is special and it basically has no value. It's just kind of a blank that we can send out. So I could say give back nothing. I could also just do this. I could just have this by itself with no data to give back. That's actually the exact same as doing this. So at this line, I'm just saying cut the function now and go back to the code I was at previously. The problem with this approach is that even though I printed out some line of code, I'm still continuing on with my code. So we can see down at this point, I'm calling add up. It's inside a print function, but I'm still calling it at that point. But then I would be allowed to continue on with all of the code down this way, even though I cut this function down like this. And if I'm dependent on the data that comes out of that, so if I'm calling this function, it gets cut because I gave it bad data. And answer is actually a none type. It has no data because I gave no data out. Well, if down this point, I'm using this to do something, all my code is going to get messed up and I might not know exactly when something happened. So this kind of manual approach is maybe not the best. So instead of just cutting the function and printing out a manual message, maybe we'll do something like this. We'll kind of raise exception instead. And we can see when I get to this point, what happens is the whole code quits, not just this loop, not just this function, but all of the code stops. And I get this message on my kind of bug screen. So now I can manually put some piece of text on my screen. So right now I just say it quit because of some bug. I could put the specific line that was at. I could say like it expected an int if I want to kind of help the people using this piece of code. So I could specify this message. So that's one way we could do it, and that's probably a safe way to do it. The second way, equally valid, is to do this. I could raise, instead of just kind of like a general exception, oops, I could say, it's not just an exception, it's not just a bug, it's a specific type of bug. It's a type bug. And I'm still allowed to put some custom message that prints out if and when I get to this line. So if we look down now.
Can you show us an example of that bug, please? That raise error, only positive numbers are allowed.
Say again?
Can you please show an example of that bug that raise type error, only positive number? Yeah, the supplied variable. Positive.
What do you mean? So this,
no, the one before here.
This
here.
one.
Right.
Okay, yeah. So if I put this data into it, that's fine. But if I put a -1 in,
Correct.
we can see I get this, it's a value bug. I have the type that I'm supposed to have. I have an int or maybe a float, but its value is mistaken. So if I look up, I got inside this line of code, it was an int, but it was negative. So then I got to this line, I cut the whole code, and I printed out this message. In this little F and this thing we'll look at today, so don't get too confused about this special type of printout.
Right.
Yeah, we'll get to that in a second. I apologize about putting that ahead of it.
Okay.
Yeah. So we can add these to the code. We can add these to functions. We can put this any place we want. And that's going to help us kind of handle bugs neatly like that. And that's something that professionals need to do a lot. Only about half of what professionals do is kind of making the code function. And then the second half of coding is testing, maintaining, documenting code, doing things like this so that if and when something happens, they help themselves fix it. So this is the big thing in any type of coding. Coding it is just half of it, but then adding in all this bug handling is the second half of it, really. Okay. One last little useful thing, not so much with those kinds of bugs, but just kind of like testing in general, is this statement. So what this does is actually, let's take a look at this block of code. We can see we still have my add up function. I took away all the bug statements and things like that just to neaten it up. So I'm giving it some list of digits and I'm just adding them up. And we can see at this point, I'm basically doing a test. I'm saying if my custom sum function is not equal to the output of Python's built-in sum function, raise exception sum bug. So what I'm basically doing is I'm saying I can trust Python's sum function as I test my code and we find out about functions. I just want to compare my custom function to the sum function. If the output is not equal to the expected output, I'm raising some exception. So I can just do this with 2 lines like that. So if I change this out, instead of handing back total, I just hand it back, something. Let me comment it out. We'll talk about that in a second. We can see I get to this line. My custom sum function is not giving back what the sum function should actually do. So this is how we could do this kind of manually. But the exact equivalent of these 2 lines of code is this line of code with this new statement. So what this is basically doing is it's saying, well, let's read this right to left. It basically says, calculate the sum function given these nums. If that is equal to my sum function's output, do nothing. But if it's not equal to it, then this is going to activate. Oops. Then this is going to activate and we'll get something like this. This will kick in if and only if this clause fails. So if I add this back, we can see nothing is happening. So this is basically a way of like adding in a test to my code. And basically it doesn't take up any space in the print statement in the console. It basically only speaks up if this test fails. I can just kind of leave this on my page. And if at any point I kind of change this function and play it again, this is going to catch me and let me know that I made a mistake. So this is just one last tool in the toolkit, this being basically equivalent to this. This one I'm going to skip. This is kind of the same deal. We can kind of guess what these things mean, try, accept, else finally. These have to do with like trying to do things. And then if we have a bug doing something else, it's just a different strategy of doing it with different Python statements. I have a little example and you can click on this link to get to the W3 Schools, kind of full explanation of this. But I don't like to use these statements as much as like raised exception and things. I think it's slightly less useful, and yeah, so I don't like to use these as much, but it's good to know about, so you can look at that on your own time if you want. Okay. So now that we know how to do custom functions, we'll be getting into functions a lot. We'll be making functions, and we'll be kind of adding to the toolkit of all like the built-in functions that Python gives us. So let's just take a look at all the things that we've used and all the things that we might need to know about from now on. So this is all Python's built-in functions. We know about these two guys, print and input, kind of the opposite of one another. We have the len function, which is the length function. And that's basically going to give me how many items in something. So if I want to get the length of, the string hello, it's going to get back 5 because hello is 5 long, things like that. Sum, we just took a look at, we just did that manually. This is going to add up the sum of any given, collection, some list like we just did above, and give back the total. Minimum and maximum, min and max. These also take some list of amounts, some list 10, negative 1,000, 5.7, ... It takes some list of quantities, and it's going to give back the minimum of the maximum of those data sequences. As we move into strings today, we'll be doing that just up next, kind of text data. We have some special functions that have to do with text, and we'll take a look at these. These guys will check if a string is capitalized. That's what this one does. So that's going to give back true, false. And then this one is actually going to capitalize something. So if I say like hello dot upper like this, it's going to capitalize it to all capital hello, things like that. We have the same thing on this end. We can capital and non-capital. We have swap case to kind of say anything that's capital, make non-capital, anything lowercase, make capital, things like that. And we'll use all of these at some point, so I'm just kind of listing them now. Is digit is going to say, checks if anything inside a string is a digit. So say if I wanted to check if something is like the string, it's like a string object of someone's telephone, I might use this to check that I only have digits inside of it, and that's going to give back true, false. These two we just took a look at. Type tells me what type something is. And then this is useful with like if clauses and things. And then last two functions that you might find useful. Okay, I have a little space just to kind of practice these. All of these, as of now, and maybe at the end of this class, once we do the rest of the notes, all of these you might be able to do manually, just like we did the add up manually and kind of compare that to Python sum function. A lot of these you could do manually. And I think that's good practice. So some of these, if you have time, kind of implement them, practice functions, practice, basic logic, all the things that we've done. See if you can implement these kind of homemade, and you can use all the things above to kind of check if what you make is equal to what Python's functions output. So, you could use this to say, is my function equal to the output of Python's function? You could use this one with these and so on. I left a little space, and I have some solutions as well. But let's take a look at strings. This is the big new content today. So let's get some new stuff in. Okay, so we talked about this a little bit in week 1. A string is one of the Python data objects, and it can contain basically anything. It can have, alphabetical things, A to Z. It can have digits. It can have like punctuation, spaces. It can have like special things like tabs and new lines. It can basically have any type of text that you might see on some page inside of it. To make one, we just initialize a name, and then we set it equal to the text inside quotations. We can do single quotes, we can do double quotes. Just stick one and stay consistent with it. So, we could do something like this. Oops. Make 2 strings. It's okay that one is double quotes, one is single quotes. It's okay as long as we don't mix them inside one single string. And then just like with the last int and float type data, we had a lot of math methods. We could do addition, subtraction, all those types of things. The things that we can do with strings is we can kind of combine them, we can multiply them, we can kind of slice them up if we want to take like the play of Hamlet and slice it up into all of Hamlet's lines. We could do that eventually once we get all the tools. So that's what we can do with strings. And the basic thing you can do with a string is kind of glue 2 strings into one new one. So if I have 2 strings like this, I could make some new data object like this. I could just say, take the object name and stick it to that last name. And then I could check that. Oops. Okay, yeah, so we could see it did exactly what we want. It just took name, which is just this, and stuck it to the end of this. So that's exactly what we want. But just like anything else, we can kind of stack multiple of these in one statement. So we could say, to make this sensible, we could say take name, then add on to that a blank space, and then add on to that the last name. And then we can get something like this. So that's how we can kind of play with text data at the most basic level. We can do the plus sign. We can't do things like the minus sign and division. That doesn't quite make sense. But we could do things like multiplication, because multiplication is basically addition just multiple times. So this is called concatenation, and that's what we can do with strings. As we get into strings, it'll be useful to kind of know how to print them out nice. I know we've had some questions about like how to make strings nice looking and things like that. One way is to use what's called an F string. And this is a way of kind of combining static text and data objects. And it looks something like this. We just saw this a second ago. I slipped that into the code by accident. But it's called an F string. You just put an F in front of those quotations that you make the string with. Then you can put some kind of like static text This is always going to say my name is. But then inside these squiggly brackets, we can put some object's name. And then this will say my name is Matt. If variable name is equal to Matt, it could say John if that's equal to John. So we kind of mix static and dynamic data like that.
Excuse me, Matt.
yeah.
In just the previous example, you said print Charles times 3. So it printed Charles 3 times. So string and number 3 can be multiplied.
Yeah.
Oh.
Yeah, so we can do that. And that's basically because it's the same as this. Multiplication is just addition again and again and again. We could not do something like this because it doesn't make sense to divide text into 3. I mean, we could kind of say maybe we divide it into 3 even amounts of letters, but we can't do that in Python.
But
So we can think
multiply 3 is allowed, right? I mean, name.
It's basically just saying
Name plus
name 3 times. So glue name together with 3 times.
Okay, that is.
Which is equivalent to this.
Yeah.
You won't use this a whole lot, but I just want to mention it in addition to the most useful thing, just kind of gluing strings back to back with the addition sign.
Okay, thank you.
Okay, so let's go ahead and do an example of an F string. So I'm just going to set up name. Then I'll say sentence equals, then I'm going to open up an F string. I can do an F, I can do a capital F. It's the same thing. Then I could say, my name is. Then I need these squiggly brackets. Then I just put in name. And then I can print this out. So now we can see we get the static text, and then the instant that we run this code, this gets swapped out with the value of this object. So if I change this to John, now this is going to change as well. So this is basically just a convenience tool. This is basically replacing something like this. My name is plus name. So this is basically the same as this. It's just slightly less inconvenient to type this out than this, depending if we have to combine a whole lot of things into one text string like that. So that's how we can use F strings, and you'll probably want to get used to those because you'll see those a lot in Python. Most people use F strings instead of doing something like this. And then lastly, I know Subra, you had a question about this. We saw something like this, I think in week 1. And what's happening is with the print function, you can have as many things inside the print function as you want, separated by, commas. But what it does by default is it separates each object, comma to comma, with a default single space. So that's why this is happening. But we can actually modify the print function to say, don't use those defaults, do something special instead. So what we could do in this, if we wanted it to do this way, instead of using the convenient F string, we could do it like this, but then we just have to come in at the end and say, we say sep as in separator, and then we say equals, and then we say, what should separate each thing? Instead of the default white space, single space, I'm just going to put quotations with nothing in them to mean don't put anything between things. So then when I play that default space goes away between these 2 items. Anything you want to put inside of this, it'll come out between each item in the print statement. So in this case, I just want to change the default white space to basically nothing.
So what happened when you put just Jumbo Mambo like over there as separator? You put something there, right? You typed in whatever, right?
Yeah.
ABCD, whatever you typed in there, then how did it get concatenated to that name? Name is John, we know that. Oh, after John, then, so ACP is a built-in function.
This is like, I think it's called like a flag. It's a special, it's kind of like a special input to the print function.
Oh.
Yeah. So we can see down this way, I want to say, instead of dividing things by a white space, I put in 2 pipes. You know, you can make this anything that you want. If you want to, you could put this \n is actually how you do a new line in Python, how to jump to a new line. That's how you denote that in Python. But I just want to take away that space so I could do it this way. But obviously we know the most convenient way now is just something like this, you know. Names, the title is ... And that way I don't even have to use that because I have this F string, which is really convenient. It's everything in one basically.
And F stands for faster concatenation or faster something, right? Or yeah.
I think it might be fast. It also might be format. I don't actually know what the F means.
Okay.
I think it's the second one. I think people think it's fast, but I think it's actually this. But you know, it's an F string.
Okay. Okay.
Yeah.
Thank you. This is a good example that ACP. Like.
Yeah. Okay. Yeah. So the last thing about F string is not only can you just put a data object inside, you can also just put Python code. So I could just put 2 + 2, and then that comes out like that. I could put, you know, is 2 equal to 2, and then I get that true Boolean value. So you can put Python code inside of this as well to kind of do like immediate calculations inside that sentence itself instead of doing it ahead of time, you know, how you want to do things, but just something to know about them as well.
So that is like F string is concatenating the answer is that string and 2 + 2, the number within curly bracket, right?
Yeah, what it's basically doing is anytime it sees something inside brackets, it's saying that's not plain text, that's a bit of Python code. So it's saying, what do I do with is 2 equal to 2? I evaluate that equals true. And then I put that value inside the string at that point.
Okay.
Yeah.
Okay. Thank you.
Okay. So this is the big thing when it comes to strings. When we had like the math type data we did last time, we could, you know, do addition, do subtraction, do all those types of things. But with strings, not only can you concatenate them, but you can imagine if you have like a big chunk of text that you put into a string. Again, my example of Hamlet, you might want to kind of cut it up. You might want to say, okay, find all the places that, you know, Hamlet begins a line of the play and cut that out. So how do we kind of, you know, index, find the position of things inside some string text? And then how do we kind of cut it out and take it out like that? So then we'll talk about kind of the idea of indexing, and then we'll look at some examples of, again, how to take basically some subgroup out of the string as a whole. And it'll make sense once we kind of fully go down the lesson. But so to begin, indexing is basically just accessing some individual element, some item inside an object. So an element, oops, let me change this to code. So if I have something like string equals hello, each character is an element. If I have something like list equals, you know, 1, 2, 3, 4, 5, you know, each number is also an individual element. So how would I access like one of these at a time instead of looking at the whole thing at a time? Because again, if I have some piece of data that's like the whole text of Hamlet, obviously I want to pull specific pieces of data out and not look at the whole play every single time I use that piece of data. So indexing is just finding the position of something specific within the whole. We kind of know now that we used the range function is that Python is a 0 index. So instead of saying this is item 1, this is item 2, we actually begin counting at 0. So actually, index-wise, this is item 0, this is item 1, this is item 2, this is item 3, and so on. We kind of count back by 1, just like we saw in the range function. If I do something like this, we now see why when I say, okay, count up to 5, it begins at 0 and then stops 1 shy of 5 because it's 0 indexed, it begins at 0. This is just something we'll have to get used to. Most programming languages do this. You don't count at 1, you count beginning at 0. So it's just something to get used to. But we just,
Excuse me, is range a built-in function like print?
is what?
Range.
Oh yeah, yep, that's a function too, yeah.
That's
so
a built-in function like print, right?
Yep, so anytime you see, you know, some name with parentheses on the end, that means it's some function. And you know, if you didn't make it, it's something that Python, gave to you. It's something that's so commonly used, Python said, we might as well give it to you instead of you kind of manually building it yourself. So simple things like sum, range, finding min and max, Python knows that so many people use that. It just gave it to you out of the box.
So you are saying any string, and after following a open parent and close parent, that is a function given to me by Python. So that, as opposed to me creating a function, can you just write quickly how if I look at a code, how do I distinguish? Like this is a Python given function, built-in function, or created by programmer function?
Oh, you can't. The only way you can tell. Let me go back up. Well, it's quite simple. The only way that you can tell is it can only be a custom function if you made it. So if you know that you made something called addup, like we did.
Oh, by definition?
Yep. Yeah, so this one we made.
Oh.
But this one, I'm calling it, but
right.
I didn't write this. I don't see definition sum any place on my page. So that code is kind of hidden inside Python as a built-in tool.
Okay.
Yeah, so if you didn't make it, Python did. Yeah.
Okay, got it. And also the color difference. Maybe just for this editor, I'm not sure, but the color is different. Like definition add up. Or no, I'm wrong.
No, that might be the case. This is like a yellow brown, and this is just black. Maybe it is distinguishing. I don't know. That's a good point.
Where you defined on the top, it is the same color. My observation is incorrect.
Oh yeah, but yeah, if you defined it, then you know that it's custom.
Okay. Thank you for clarifying.
Yep. Okay, yeah, so Python is 0 indexed. So if we imagine a Python list, as we can see in this image, but let me just write what it looks like in Python. List, you begin with this, and then you just have, values like this. ... Again, the way you index is you count at 0, and then you go up by 1. So red is index 0. This is index 1. This is index 2. So on. So again, just something to get used to. You can also negatively index, which is the same thing. It's finding the position of something. But it's just basically counting from the back leading up to the front. So in typical indexing, we say, okay, H is the 0th position. E is the 1th position. This is 2 position. This is 3 position. You could also begin at the O and say, this is the -1 position. It's the last element. This is the -2 position. This is -3 position, and so on. That's useful on occasion, and it's the exact same idea. But we'll just stick with positive indexing, just while we get used to it so we don't get confused. But it's just 2 ways to kind of index something. This one begins from the beginning and goes to the end. Negative begins at the end and goes to the beginning. And we'll see ways that it could be useful to use negative indexing, but we won't waste too much time with it. Okay. So that's what an index is, but how can we kind of get those items out of the whole now that we know an index? Well, it's quite easy. We just say, let's take some object. And an iterable object is, again, just something with distinct elements inside of it. So a string, a list, these each have individual elements inside of it. So that's what that is. And then we just stick the brackets on the end, and then we give the index position like that. So as an example, if I wanted to get position 0 of my A data, I just do this. I say, get the 0th position of A, just like that. I can do the same thing with the list. It's the exact same notation, strings and list, so that's helpful. Just like that. To get the last element, you would do, what is it, 5? Oh no, it's not 5, it's 12. Oops. Okay, yeah, so we see what we did. I put in 12 because I have a note, this is 12 long, but because I 0 index, if I put in 12, it says that's out of range. And that's because this kind of thing next to it is position 12. This is position 11 because I begin at 0. So I had to put in 11, which is 1 less than the length because I kind of backtrack by 1 like that. So that's how I can get the last element of this. And again, same with the list. Same idea like that. If we take a look at this example, say we have 2 pieces of data, hey and bye. You know, how can we get the same position out of each one at the same time? Well, we could do something like this. We'll go 1 step at a time, kind of right to left. So we'll say, okay, the length of A is 3 like this. So I'm going to take range 3, which is going to give me 0, 1, 2. So that's what this is going to give me. And then I'm going to print out that index position of both A and B now that I have kind of a manual index of both of them. So I can even add in I. So we can see we know how to do this. We know how to get 0, 1, 2. But now that we know how to index, I can kind of get the same position out of each one at the same time that way. So that's how we can kind of get the same thing out of multiple things at the same time. And that'll be useful a lot in kind of big level Python. We saw above, with this one, when we got the last element, we kind of had to manually count to the end. We had to know this is 12 long. Again, if I, instead of A equals hello, if I have Hamlet equal, you know, full text of Hamlet, obviously I'm not going to manually count that to get, you know, 20,000 or something. So how can we do that without doing that? Well, we could do something like this. Say index out of A, and what position is it? Well, it's going to be length of A minus 1 like this. And then we get that Y. Because again, yeah.
Excuse me, Matt, I'm trying to understand that for I in range length of A, that one, what can you please explain that one once more, the output, how it is happening?
Yeah. Okay, so we'll go right to left, kind of inmost to outmost. So length of A is 3. The length of this. So that's equal to 3.
Correct.
Then we can basically say, let's just swap that out so we can kind of get an idea of what's happening. So
right.
Then we say for I in range 3, so that's going to give me back 1 at a time, 0, 1, and 2, just like we've been doing.
Right.
If I take this away, that's what we've been doing. We know how to do that.
Right.
So then now that I have these, I can kind of think of them as index positions. because I only have enough to kind of fill up this. That's why I limited it to length of A, because I only need that many indexes. So I have 0, 1, 2. That matches up with these index positions of 0, 1, and 2. And then I can say, I'm going to print out I. I'm also going to print out the ith position of A, which is 0, then 1, then 2. And at the same time,
you are printing this. Okay, okay. In the
Yeah.
same line, you are printing it. Okay.
Yep. And then at the same time, I can do B. I can get the 0th position, the 1th position, and the 2th position.
Okay.
And then I can push play. And then, yeah, we can see I get H and B, E and Y, Y and E.
Okay.
Yep.
Okay. Okay. Got it. Got it. Thank you so much.
Yeah.
Thank
No,
you.
this is definitely one of the most confusing things about coding. And it's kind of, this is kind of like an abstract example, you know, it's just, you know, digits and things on a page. But I do promise this is incredibly useful to doing actual things in
Yeah.
Pythoning.
The
Yeah.
for loop, right? The for loop.
Yeah.
Exactly. Yeah.
Okay. So that's the basics of getting a single index position, getting a single element out of something. We just use this notation. But what if we want to get like a subgroup of something instead of just getting out, you know, H, maybe Y? What if we want to get like HE? Or what if in the Hamlet play, we want to get, you know, the chunk that is Hamlet's second line, given that we know those index positions, you know, when it begins and when it ends. We can do something that's basically the exact same as the range notation, which is useful because we only have to kind of know one idea. And basically the idea is instead of just getting out one element, we say basically, okay, take that object and begin to cut at this point, stop cutting out at this point, and step, again, like range, cut one by one, you know, get everything. If we want to get every opposite thing, we could do 2, things like that. But this is what we want to pay attention to, is basically when we begin and when we stop cutting, and then we can get out that substring or that sublist of the whole. So we take a look at these examples. You can see I just have the library telephone as a string and a list, and we'll just practice how to get out a group of things. So if I want to get out the area code, basically I want to pull out 973, and maybe this is now something that we can imagine doing in actual data. If I have some business and I have a whole list of telephone numbers, maybe I want to pull out the area codes of all of them, and then I can compare that to some list to see all the places of those people that I want to call. So how would I do this? You know, I would say, let me put this inside a print. I'm going to say out of S, I'm going to index. And now it's just like range. So I can say, I want to begin at 0. And then instead of commas, I just use colons with this. That's basically the only difference from range. So I'm going to say from 0, go to, and then I want to say, I'm going to count my index positions. I want to go 0, 1, 2. So 973 ends at index 2, but just like range, I have my stop sign 1 beyond that. So I'm going to stop at 3, so I get 0, 1, and 2. So if I do that, now I get 973. This basically says begin at index 0, go until index 2, stop ahead of index 3, just like the range function. So that's how we can begin to cut out, you know, sub lists of things. Just like the range functions, a lot of this can be defaulted. So the same thing we just did, we could say the identical thing with just this. So if I do that, Python is assuming the default is 0, and I can just leave that blank. So if I do that, this is the same as that. but I have to put in that colon because if I take it out, then it's saying just index out this single element at index 3. So I need to say go until index 3 with that colon. So I can do it that way. And if I wanted to do it out with nothing kind of assuming the defaults, this is kind of the full way to write it out. Not that you would need to, but this is what all of these imply. Begin at 0, stop at 3, and get each element, go one by one. If I like change this to 2, then you can see it skips the 7 like that. So the default is step 1 like that.
How do you explain the second print statement? S then within
This
square.
one?
Yeah.
Yep. So this one is just like the range function, when we can kind of like default the step in the beginning by not including them. Like if we had this, we know this is the same as this. 0 is the default, so we don't even need to put it.
Oh.
So that's what this is doing. It's saying, since I have a blank, it's just assuming I have that default 0 like this.
Okay.
The only thing you have to watch out with is if you take away the colon, then it becomes a single index position instead of like a substring range like that. So this colon is saying go until 3. It's denoting that it's a whole span like that.
Oh, okay. All right, thank you.
Yeah. So if we can do that, we'll do a couple additional examples. So if we want to get the middle 3, we want to get, instead of 9, 7, 3, we want to get 3, 7, 6. Same thing, we just have to think like it's a range function. So I'll set up my object name and then my index little symbols. And then I'll say, let me count these out. So this is index 0, 1, 2, 3. So I'm going to begin at 3. And then I can even, let me just check that. So yeah, I'm beginning at 3, 7, 6, but I'm going all the way till the end because I haven't put in when I'm going to stop at. So we can go back and count 0, 1, 2, 3, 4, 5, 6. So I want to stop at 6 because the last one I want is index 5. So we can check that. And we can see what we want like that. And then finally, if we want to get just the last digits, we can do it again. This time I'll do the list, so I'll use L. So I'm looking at this guy now. So 0, 1, 2, 3, 4, 5, 6. And then again, I could count to see how many digits this is to, put in the stop. But if I just have the colon and then nothing, the default is all the way to the end of the string. So if I say begin at 6, colon nothing, it just says 6 all the way to the end like that. So I don't even have to put the stop. The stop.
Here, because you started with list, the output came back as a list within a list 1006, right? But before we did not do list, that's why it came 376 or 973, right?
Yeah, I just switched data objects because you can do the same thing with strings and lists. If I switch this to the L,
right,
then we can see, yeah, now it's the list because it's pulling out of this. Okay, but it's the same notation, yeah, with both of them. Exactly.
Okay, that's what I wanted to verify.
Yep. Okay, yeah. Yes, if you want, I'll leave this. If you want to go back and try this again, you can do it with negative indexing. If you want to, do a little bit advanced stuff. One last neat thing we can do is we can kind of flip a whole thing on its head. We can take a string and then kind of flip it all the way. And the way to do that is just like the range function. If we step by -1, we can count down. We can use a -1 step in this slice syntax to kind of go the opposite way. And I'll just tell you the way to do this is something like this. So we just kind of say, we just kind of assume these two defaults. So we just say Python use the default beginning and the default stop. but all we want to say is do it special, do it the opposite way. So count back end to beginning like that. So that's how we can flip something on its head if we want.
So the default start is 0, obviously. And the second colon, the blank colon means like up to the end, right?
Yeah. So this one's a
Okay.
little confusing because the default is usually 0 and the stop is usually the end.
End,
But
right.
I guess Python just knows if you say -1, it's basically switching these two defaults. The beginning is now the end, and you want to stop at the beginning. So it's a little confusing. This one's a little special.
Yeah.
So you just maybe need to memorize this one. Yeah.
Okay. Okay.
Okay. So you can imagine, just like the range function when we counted up to 10, but we went by odds and went by evens, I'll leave these two practice spots that you can do that. I'm just going to wrap up the class now. I have a lot of practice problems and all these solutions. So if you want to do that, you can. At the bottom, some additional practice problems, things like that. I have a couple kind of long problems in the middle. All of these you'll be able to do now. And I have some additional notes to kind of explain things that we didn't fully look at yet. So you can kind of do this on your own. Lots of problems. This again is kind of a long problem, but it's just, step by step. It's everything that we've done up to this point. It's just a lot of steps at once, but each individual step is easy enough. And then at the end, we just have, well, again, one of like the big problems with the solution and a little explanation as to how you might go about it and some tips. So next class, we'll look at some of these. And if we don't talk about ones that you had questions about, you can just ask about them as well. And then next class, we'll actually look at making an encryption function. So we'll take some message and encrypt it, and then we'll be able to flip it and decode it back to the original message. Now that we know how to do things like slicing and doing stuff with text data, the next thing will be that big function, and that'll be the wrap up to the class.
Thank you so much, Matt.
Yep, so you're free to go. If you have any questions, I can hang out, but obviously you're free to go, and I'll see you next class. And I will post the video on YouTube, and I'll send out the link as well in between now and next class.
Okay, wonderful.
Thank you, Matt. Yeah, definitely. You're a great teacher. I just posted a question, like, how, do we use Python in library? Do we put it to practical use?
How do we use it in the library building?
Yeah, in the library system, or yeah, in the building, yes.
Well, we don't have anything special at the library. You can just go on, if you visit us, you can just use the public PC, and you can continue to use Colab. Next week, I'll also, in addition to teaching the final Python topics, I'll talk about additional websites that you can study off of, additional websites that you can do the Python coding itself on. So a lot of those outside things to take you on the way to becoming like an intermediate student. So we'll talk about some of those places next time as well.
Yeah, that's great. But what I want to know that how do we do we really put Python language to practical use in the library system? Like, we're learning this language, right? So can it be used in the system for library functioning?
I mean, yeah, you could. Like we talked about in week 1, with Python, you can do anything that you can do with any type of coding. You could build games, you could build websites, you could handle and manage databases. So if you wanted to use Python in like a library setting, you could use Python to make a library website. You could use it to make the back end of like a catalog system and keep track of patron accounts and things like that. Yeah, so you could do almost anything you can imagine, some digital product with Python.
All right, thank you.
Yeah.
Matt, one quick question. Like,
Yeah.
I was able to figure out the Colab, the Python 2, Python 3, etc. But
Yeah.
with that download or upload, like the exercises, if we do or any homework we do on that Colab, is there any way you can see that, you can check it, or we do it, it stays with us, with our drive?
So what you do on those files is kind of local to you.
Oh, okay.
But I mean, so what we could do is you have the solution, you have most of the solutions in this handout. I pointed out some of the solutions like this spot. So you have some of the solutions. If you
Right.
want to kind of give me the code so I can look at it and you can ask a question, you can just send me a copy of the file. So what you could do is you could go to File, and then you could just download that IPNYB file that you see me send you. This is how I send it to you. So you could download it, and then you could like email it to me or to anyone if you wanted.
Okay. Okay.
Yeah, so that's how you can kind of give it to people and things.
Oh, okay.
Yeah,
Got
that's
it,
just one way.
got it.
Yep. Okay, yeah. So I'll see you guys next week. Thank you for coming.
Thank you, Matt.
Yep.
Thank you very
Okay.
much.
Bye. Have a good evening, guys.